Welcome everybody to this PCB-Investigator video tutorial. In this video I want to show you how PCB-Investigator can help you to analyze your PCB layout regarding the different requirements for net-to-net creepage distances like they are defined in the DIN EN 60664-1 document. But before going deeper into the creepage analysis functionalities of PCB-Investigator, I will open a design and show you a few other things, like how to first find and highlight nets and net groups. So I have a quite good layout example here. It is a power supply unit for high voltage, and as you see we have a 4-layer board, and yeah, there are a few components, and the board is round about, let's see, 220 to 120 millimeter large. For analyzing the layout, it is essential to have good possibilities to find and highlight nets. And I will introduce a few functionalities of PCB-Investigator to you. The first possibility to find and highlight the nets is to use the normal netlist here. So in this netlist dialog, all the nets are listed, and by double-clicking on them we can just highlight them. So in that case we have a few letters or a ground, none nets is, yeah, here we have a good net, for example. And as you see, the net is highlighted, including the components, as this option is set here, and it is highlighted on all the layers. So currently it is used on the red and the green one, so it's on the top layer and on the bottom layer. And as you see, maybe the other tracks on the other layers are still a little bit visible, so we call this highlight mode or low light mode. And with this track bar you have the possibility to change the transparency of the non-selected elements. So it's a good function to make a net visible but still have an idea about the routings on the other layer on this in this area here. Of course, we can also just select the net by clicking on it. So you can use the normal select net mouse tool, and I'll take the best view option, and I click on the net, and again the net is highlighted completely with all the components, and I still see the layers with the colors. So I see the red one is the top layer and the yellow one is the bottom layer, and I see the whole net. An interesting alternative to select only one net is to use our crossover mode. When doing the crossover mode, we see that not only the single net is highlighted or selected, but also we jump over small components into the next net and select the next net also. And in that way, the whole net combination, let's say, is highlighted. Larger nets like power nets or ground nets are ignored. So we just see the whole path going also through small components, but not going into large nets like ground, for example. What you also can do to select nets is to start from component. So for example, I select just this component here, and then we have the option nets of component, and a small dialog opens here. So on the left I see all the nets which are connected to this T900 component. And if I just say select nets, all of them are selected. All of them is not really true because I have an exclude filter set. If I would do no filter, then also ground would be selected. And that makes my view, or this is a little bit confusing sometimes. So I have the possibility to put nets like ground in an exclude list, and you see as soon as I activate the exclude list, the GND1 and SGND net gets red. So when I do the select nets button, every net is selected but not these two. And that makes it very, very easy, also with auto select, to get an overview about the connection from one single component. So it's very easy to select the nets of a selected component. When reviewing a layout, it is also often interesting to see the length of each net, and therefore PCB-Investigator offers this small button here, and the length of each net is listed here. This is mostly interesting for high-speed designs when the bus lines must have the same length. So this can be easily controlled with the net length dialog of PCB-Investigator. But in this design, I think there is no high-speed buses, so it's not so important in that case here. Another very interesting highlight method to get a quick overview about netsys and connection to components is the Highlight Power Pins plugin. So that one automatically recognizes ground and power netsys and gives the possibility to highlight the pins of those components. So as you see, a few pins got the color blue, those are the ground pins, and a few other pins got the color red. So this is the power pins. So now it's very quick and easy to find and to have an overview about which component is connected to power and which one to ground. When I now activate the copper layers also, I have the possibility to activate the net name label in the tracks, so I can also see that the SG&D net is connected to the pin 2 of this component 512, and the 12 volt S nets is connected to pin 1. So that's why the pin got the color blue or red. But as you see, it's very simple and very quick to see which pin is connected to which net, and the color also helps to quickly identify power and ground. But now let's go a little bit deeper in the analysis functionalities of PCB-Investigator. I just forgot to reset the pins, so I will reopen this and reset the color of the pins. And now what I want to show you is how to work with the net group dialog here. So just to repeat, we have seen the net list, we have seen the highlight power pins, the net length, and also the nets of components. This one is to generate a net list if it is not already generated or if the layout changed. So if you modify something, you can regenerate the net list here. But what I want to do is to show you the net group dialog here. So when starting the first time the net group dialog, he asks if net group should be automatically created. So in that case, I don't want to do this. And now I get this dialog here. So we can import net group definitions, for example from Cadence, which is a DCF file, and from some other tools with XML files, or of course you could also write a script which imports net groups from any file you have. So and therefore we can also support you. But in that case I will just import it from a file I have already. So in that case we have 4 groups. Rest, which is every component, which every net which is not in one of those here. We have the HV, the high voltage net. We have VN net, and we have the ground net. What I want to do is I want also to modify a little bit and add a new group. I know that there's a SG&D net. So here is the list of netsys in the group rest. And this one I just remove. And now I create a new group manually, an SG&D net. And here I try to find SG&Ds. And I assign those netsys, those 2 netsys, to my SG&D group. And now I just save this. And now the groups are assigned, and it's quite easy for me now to select a whole group. So I can use again different highlight methods to highlight a whole group of netsys, like SGND or the high voltage net in total here. This is also interesting when combining it with a 3D view. So I just generate the 3D model of this printed circuit board. Takes a few seconds. And here it is. So this is just the high voltage net, but when I just unselect everything, so I go selection and clear selection, here I see the whole board. So we have a very nice 3D view of this board here. But now it's very simple for me to just click on the HV, on the high voltage net group, and only all high voltage nets, including the components, are selected now. So, and I can exactly see how they are routed through the different layers, how they are connected, including stack up information also, and the routing via all the layers for the whole high voltage net net group, let's say, which is consisting of 19 different nets. Of course, I can do also the same for the VN net, for the SGND, or for all of the others. So grouping together the nets is always interesting if you have distance rules, for example, that we will see later with a Creepage check, and also for visualizing a whole group of net with a few clicks only. I will now go back to this 2D view, and also what we can do is assign a color to this group. So let's just say this is green, and the SGND, for example, I will assign a color red, and I apply those color to the layout now. So when I go back to default and select this layer, so now I see red was not the best color because the whole layer was red. So maybe I will change this here to some orange color here and apply it again. So now I see green is my high voltage and orange is my SGND net. And this color information can also be exported or imported again. So you can export those information, and if you have a new index of your layout, you can re-import it, and with a few clicks only you have again your colors selected for all the net groups and for all the nets. So all this information which we have done here, we can export and import again. The next thing I want to show you is the analysis function within the net group wizard. So this analysis function is useful for determining the minimum distance between different net groups which we defined here on each layer separately. So we have the possibility here to select a group A. So for example, we select the high voltage net on the one side and the GND1 on the other side, and then we enter a minimum distance which we want to have, and we get a lot of entries here which indicate that the GND1 nets to the HV net has distances around about 1270 on many places. So if I click on one entry and I will just deactivate the net labeling here, and we are now on the top layer. So when I only activate the top layer, I see that we have between the green one, which is our high voltage net, to the red, which is just a layer color red and which is belonging to ground, to GND. We have a minimum distance here of 1270. We checked for 1300. So we find all the places on each single signal layer where those two groups are closer than 1300 micrometer. Of course, we can now export this list, for example, to the HTML report, and I override that one here, and immediately I get an HTML website indicating all the different group and net-to-net distances out of our result list from our check here. So PCB-Investigator offers a lot of possibilities for doing those HTML reports now. So this is quite new and works perfectly. So this net group distance calculator is already a good way to measure distances to avoid creepages. But especially for creepage, we have another possibility, an own analysis function working even better when going also around the PCB edge is needed. And therefore, I just go back to the normal view and go to Analysis tab, and here we find the Creepage Measurement button. In this Creepage Measurement dialog we have a few more options than in the Net Group wizard. So first is we have the possibility to allow the creepage flow via the board outline and via routings. So we can also check for inter-layer distances, so from layer top to layer bottom around the PCB edge, for example. This is what the net group distance check does not do. In the net group dialog, the net group distances are checked for each layer separately. And then we can define an outer distance and an inner distance separately, a maximum value for those. And we can also define how many steps the creepage flow is allowed to do. So 2 means that if I want to measure between a net group A or a net A and a net B, I allow one net in the middle. So the creepage flow can go from A to C and from C to B. So this is 2 steps going above one other independent net. And the check can be done for 2 nets or also for 2 net groups. And what I will do is I will select the net group high voltage again, and I select the net group SG and D. And now I will do 2 different checks. So as you probably know, the needed distance for creepage is depending on different parameters. The first one is the voltage of the nets. The second one is a material group, and also a pollution degree is the third parameter. And I have found a table here in the internet. And what I want to do is I will check 2 different values now. As I know the net has maximum 400 volts, so I'm in that line here. And then I assume that we have the pollution degree 1 on the inner layer. So that's why I added inner distance 1 millimeter, because 400 has 1 here. And then for the outer layers, I assume this value 5.6. So I do the check with material group 2 and the pollution degree of 3. So by the way, this table is coming out of these norms, like written here. So we do now 400 volt, 1 millimeter distance on inner layer because pollution level 1, and 5.6 millimeters on the outer layer as we assume material group 2 and pollution degree 3. So now I will just click start and do the calculation. So after a few seconds I get a result list here. I will move this dialog away as we don't need it currently. And so here we have our result. So let's start with the first entry. When I click here, I see the distance which is measured, and I see we are working from the bulk layer on bottom layer, which is a high voltage net. We go via this here, and this is a routing. So it's on the drill layer. It's a routing which the PCB layouter included to increase the distance between these two. Because without the routing, the distance would be, let me just do a measurement roundabout, 3 millimeters. And as the PCB designer included this routing here, the minimum distance between those two nets or net groups is enlarged and is 5.4. If we start on the bottom layer, go to the routing, walk down in the routing to the top layer, or not walk down, walk up to the top layer, and then the distance to the top layer. So this is 5.4. Second entry is quite similar. It's on the bottom side. It's also a high voltage net here, and again we measure around this routing here to the SGND net, also both on bottom layer. The third entry in the list is 5 millimeters, which is again on the bottom side, but in that case we don't go up in the routing, we just go to the routing on the bottom layer and directly to the SGND on the bottom layer without going down. So the distance is 5. The first one was 5.4. What we also can do, and I will show it in this point here, I can make a 3D view. Again, the 3D model is calculated. So I open the 3D view in a separate window now. So here's the whole PCB, and I will now sync the selection with PCB-Investigator and show only the selected elements. Currently nothing is selected, and now I want to see this error, so this measurement here, I want to see it in 3D, so I sync it with the 3D view, and now we see that here on the bottom layer something is connected. Until now it's not yet selected, but I can do a selection also here. So now I see that going around this routing, these two nets have a distance of 4 millimeters. The first entry we had, this one was going from bottom to top through the routing, and I can also synchronize that one. And now we see how the measurement is going through the routing from the top signal S-ground net, going down through the routing to the bottom side, and then he measures to this high voltage net here. So PCB-Investigator really measures through routings, through the edge of a PCB, and measures the creepage distance between any two nets. Again, of course, we can also see the components, for example, but also if we switch them to transparent, yeah, it's not so easy to recognize something here. So when just viewing the selected nets, I think it makes more sense in that case. But now we have still two more entries, and those two more entries I want to explain a little deeper, and because it has to do with this 2 here. So the 3 measurements we had so far were just going from one net in the HV group to the SGND of the second group. So without going through some other copper. It's just a direct connection via the outline or via a routing, but not going above other copper. But I allowed also to go via one other net. So this was this 2 here. And what we have is 2 other results, and when I activate this result here, I maybe have to change something for the view to make it more clear. So the measurement which was done is to go from this high voltage net, it's again green, go on the top layer into a totally independent net. So this net, this red net, this D802 on line 2, is not in the high voltage net and is also not in the SG&D. It's just some, let's say, foreign copper. And PCB-Investigator measures the smallest distance, the shortest distance, for going from the high voltage net into this copper. And when he is in this copper, so I will just select the net. Let me select the net here with the normal best view option. So we go here, and this net is on many layers, so it's in all signal layers. So we enter the net on the top layer, and here we leave it again, and we leave it on the signal layer 2. And then on the signal layer 2, so just we'll deactivate the other one. So now we are on signal layer 2, and we have a creepage to the corner, to the edge of the PCB, and then going down to the bottom layer and entering the bottom layer and entering into the SG&D on the bottom layer. So you see in 2D it's not so easy to follow up this measurement, but again I just repeat it. We are going from high voltage net on top layer to the net D802 net, also on the top layer. There's a creepage flow here. Then we are in this copper, we are in this net, and this net is on all 4 layers, and it's also on the second layer, so on signal layer 2. And then the creepage measure is done from this signal layer 2 in the inner layer to the edge of the PCB, and from the edge going down to the bottom layer, and then entering the SG&D net on the bottom layer, so this one. And in total this is 3.8 millimeters. It uses 58%, that is 3.28 millimeters of our rule for outer layers. So from the 5.6 which we entered here, 58% are used on the outer layer, 33% are used, which is 0.34 millimeters, is used from our check value inner distance. So in total we have 96% as also 3.47, 3.57%. That means 0.2 millimeter is going on the edge. So on the outer edge here we're going down from signal 2 to bottom. So this is a distance of 0.2 millimeters. And in total we have 96% used of our maximum distance we entered. So this is less than 100%, and that's why it is reported. And this one is also quite interesting to see it again in 3D. So I repeat 3D here and synchronize this one and select also the nets. So what we can see is on the top layer we go from the high voltage net into this totally independent copper. Then we go through this copper to the outer edge on signal 2, go to the PCB edge, and the creepage is going down on the outer corner and entering the SG&D on the bottom layer here. So these measurements, I would say it's totally impossible to do this manually. So without PCB-Investigator, these measurements I think are not possible to do with just mouse clicking or something. So it's a very, very mighty measurement, the creepage measurement, which is included in PCB-Investigator, and you can enter also how many steps, how many different nets are allowed to be in between of the 2 net groups or nets which we have to measure for the creepage distance. But as I said, I also want to do a second run for this check, and therefore again get the table. And I would just want to assume now that we have again 400 volt, but I will do a pollution degree 3 and material group 1. So this would be a value of 5 millimeters on outer and 1 millimeter on inner. And I think the PCB layouter of this design was also routing according to these rules. As soon as remember, there's no entry here, so these rules are fulfilled in the design. There's no creepage current more than these distances between the high voltage and the SG&D net. So this is great, and now you can also be sure that the rules you wanted to have are really applied and they work. But you also have the possibility, of course, to use the table and do some other checks and maybe go backwards and find out which level, which pollution degree your design fulfills, which pollution degree it does not fulfill, and maybe find the areas where it makes sense to do a few more improvements. Okay, so we are now at the end of this video tutorial. Hopefully it helped you to see what is possible with highlighting nets, measure between nets, defining net groups, defining colors, getting the length of nets, finding nets according to the net list or starting from a component, and also how the creepage analysis works, and that it is a very, very mighty tool and simulates the creepage also going through routings and going through the PCB edge, and all those measurements are, I would say, impossible to do it manually, and PCB-Investigator here really helps you to review the design. We call our tool also the perfect design review tool, and PCB-Investigator here is offering a lot to help you to do great PCB designs. So thank you very much for watching this video tutorial, and for more information please visit our website www.pcb-investigator.com. Thank you.